Hey guys, Mrs. Traver here. Today we're going to do our last section of trigonometry, which is solving inverse. So what I mean by that is we're able to solve for all of our sides, but we haven't yet solved for angles. That's what we're going to do with inverse trigonometry. So our learning target for today is you'll be able to develop strategies to recognize which trigonometric ratios to use based on the relative position and reference angle given the sides. Your success criteria is you can decide which trig ratio to use with SOH-CAH-TOA, as well as determining when you're solving for a side versus an angle. Let's jump in here. First off, I'm going to talk about inverse operations in general. So we know that if we were solving a problem that looked like this, x plus 2 equals 5, in order to solve that, we would subtract 2. So I think I'm writing in a weird color. Let me get myself in order. There we go. So we know we would subtract 2 to cancel, and this cancel means it's an inverse. So addition and subtraction are inverses of each other. With 5x equals 35, we would have divided to undo this multiply, and this cancel means they're inverses. To get rid of a square, we would square root both sides. Exponents and square roots are inverses. Lastly, to get tangent out of the way, to get a trig function out of the way, you have to use inverse trig function. So, for example, if this is a situation where I want to know what's theta, then I need to figure that out. Let's move forward and try a couple with just the calculator first before I show you a problem. So, say I want to know what A is in this situation. I need tangent out of the way. And something that's weird that I see students do is they try to divide by tangent. Well, tangent isn't a thing to divide by. You have to undo it. So it'd be like dividing by a multiplication sign. Like, it doesn't make sense. So I've got a picture of your calculator. This is a TI 30XS model. So yours might look similar if it's a Casio, or if you have the 84 version or the 84 Plus or the color or whatever. I'm kind of a calculator snob, can you tell? Anyway, so to get rid of tangent, we have to do inverse tangent to both sides. And it looks like this, tangent to the -1. Weird, I know. So on the left, I'm going to take tangent of -1 to both sides, and on the right, I'm going to take tangent of -1 to both sides. So tangent inverse tangent A cancels. There's the cancel. A is now by itself, and on the right, I have tangent inverse of 2.0503. This goes in my calculator, and I want you to notice where it is. I'm going to use the scientific calculator on Desmos because it's easy to show, but if you're using this one, I want to show you where it is as well. So here's the tangent button that you've been using. To get inverse tangent, notice it's in a different color. In my picture, it's green. So I would use the second button, and then I would hit this button, and that will give me tangent inverse. So on Desmos, I'll show you what it looks like here. What I've been doing is just typing them, or you could hit it here. If you go to the function key, you'll see the inverse ones as well. So that's what we're going to use. Inverse tangent of 2.0503, which is 69.9999. It's pretty much 64. So A is approximately 60. Whoops. Go back. A is approximately 64. And since we're looking at an angle here, it's got degrees on it. Let's do another one with cosine. To get rid of cosine, I want to inverse cosine both sides. So it'll go away from the left, and I'll just have z. On the right, I'll have cosine inverse of 0.1219. Let's put that in our calculator. Cosine inverse of 0.1219. 82.998. That's about 83. So z is approximately 83 degrees. Let's try it with a triangle. So here's a triangle. Looks just like what we've been doing. Let's set up SOH-CAH-TOA. I've got my reference angle. This time there isn't a number there. It's theta. Across from our reference angle is an opposite, and there's nothing there, so I'm not going to write it. Across from the across from the right angle is hypotenuse, and next to our reference angle is adjacent. So I've got an A and an H, which leads me to cosine. So in this case, I have cosine of my angle is theta equals adjacent over hypotenuse, so 12 over 24. All right, 12 over 24, by the way, is 0.5, so cosine theta equals 0.5. Let's get rid of cosine by taking the inverse of both sides. It'll go away from the left, and it'll be on the right now. So inverse cosine of 0.5. Inverse cosine 0.5 is 60. So in this case, theta is 60 degrees. Let's try another. On this one, let's label our sides. Across from the right angle is hypotenuse, which there's nothing there. Across from our reference angle is 8, that's opposite, and next to it is adjacent. So we've got theta, opposite, and adjacent. That's a tangent formula. So I've got tangent of my angle theta is equal to 8 over 8, which 8 over 8 is just 1. So tangent theta equals 1. To get theta by itself, which is what I'm solving for, I'll inverse tangent both sides. So I've got theta by itself on the left, and I have inverse tangent of 1 on the right. Let's put that in our calculator. Inverse tangent of 1 is 45 degrees. So theta equals 45 degrees. I want you to notice, by the way, since this was an isosceles triangle, each of these will be 45. Something to notice as a shortcut. Here's another one. I've got a question mark spot in this angle. I'm going to put a theta in its spot. I don't really care for the question mark, but it comes up sometimes. So I've got across from it is opposite, and across from the right angle is hypotenuse. O and H lead me to sine. So I've got sine of my angle theta equals opposite over hypotenuse, that's 19 over 27. I'm just going to leave that as that fraction. When I take the inverse sine of both sides, I'd have theta equals inverse sine of the fraction 19 over 27. Now your calculator can handle this. When you type it in, it opens up a parentheses. Just put in 19 divided by 27 in there. On mine, it'll look like a fraction as well. So I've got sine inverse of 19 over 27, and I'm going to close my parentheses here. 44.7. So theta is approximately 44.7 degrees. Number 4, I've got theta, which I'm going to put in instead of the question mark. No hypotenuse is here, but I do have an opposite and an adjacent, so that's a tangent problem. Tangent of my angle theta equals 29 over 38. To get tangent out of the way, I'll inverse both sides. So I've got theta by itself equals inverse tangent of 29 over 38. Let's type that in our calculator. Inverse tangent of 29 over 38 is 37.3. So theta is approximately 37.3. Number 5, let's see, we've got our theta here, and I'd like you to label sides and set this one up on your own, see how it goes. I'll show you an answer in a moment. Alright, I got 21.8 degrees for that one. Let's look at one more and then we'll be all set. So this one is a calculator error problem. It says Peter cannot figure out what he did wrong. He wrote the equation below to find the missing angle of a triangle. However, his calculator gives him an error message each time he tries to calculate the angle. What is going wrong? So if I were Peter, I would think about what cosine is. It is adjacent over hypotenuse. And we know with right triangles, hypotenuse is the longest side. So there's no way this could work out because his hypotenuse is not the longest side. It looks like his adjacent is longer than his hypotenuse. So I think he probably has these flipped around, but I don't really know because I don't have his triangle. But Peter's not going to get an answer to this one. And if you ever have a mistake like that, your calculator will definitely show you that. So if I try to do this, 8 over 2.736, it's going to say undefined. So watch out for those ones, but that's all we've got for today. I will